In this presentation, we are going to discuss how to perform a z-test for mean using an online calculator. And we are going to do this for research question number 5. So let's go to research question number 5. Here it is. It's asking, what is the average time spent practicing maths? And the alternative is saying, well, the average time spent practicing maths is less than a certain value. Now, I'm focusing on the alternative statement because the null statement can be written as equal all the way. So for a right tail, a left tail, or a two tail, you can use equal for the null. So you can ignore the greater sign, the more than or equal to, and just put equal for the null. So that's what the alternative is hypothesizing. So our variable there is time. So let's go to our questions and look for the variable time spent practicing. For time spent practicing, we have that question here, or on average, how long do you spend practicing math? So therefore now we can access the data for that variable. You can download the CSV format of the Excel spreadsheet, or you can view in Sheets. It will take you to Google Sheets and you can access the data there. And we have created another Google Sheet, which is our worksheet, and we have already copied and pasted the time there and cleaned it nicely. But the outliers are still there. You have 5 and 4, etc., and 0. Okay. And what we need now from a prior analysis and to complete our hypothesis or hypothesize mean or hypothesis. As you can see, the hypothesis now, the null and the alternative missing a value. So to complete this hypothesis, when I say our hypothesis, it's kind of tongue twister. Let's calculate the average. Let's put it right there. We can go to functions and click on average. Is from A1 to A39. We get an average of 58.08 thereabout. So now the alternative is saying, well, the population mean seems to be less than a certain value. Now we got 58 for our sample mean. So we are basically hypothesizing, taking the viewpoint of the alternative, that the mean must be less than 58, must be less than. So we have to hypothesize a value higher than 58. You cannot say, well, 58 is less than 50. No, we cannot, that doesn't make any sense. So we can say, well, okay, well, it seems that 58 must be less than the population mean must be less than 60, 65, 70. Okay, you can say that. You can hypothesize any value. Let's put a value which is kind of very far, little far away from 50. Let us use 75. So we can see, well, okay, it appears that the population mean must be less than 75%. Okay, the time spent, 75 minutes, sorry, the time spent, or 1.5. Let's use 90 or 1.5. It must be less than 1.5. It must be less than 90 minutes. It appears to be because we're getting 58. So let's use 90 as our hypothesized mean. Now, also, closer analysis, closer research, it is discovered that the z-test is used when we know the standard deviation of the population. Now we're talking about the average time students spend, studying for maths. This is not a well-known variable in our population. So the population standard deviation is not known. So we have to use what you call a t-test. A t-test is used when we do not have that information and must estimate the standard deviation from the sample. Okay, so we have to type in Google sample, t-test single sample calculator, and we access statistics kingdom because it's kind of user friendly. and our tail is left tail, because we are hypothesizing that the population mean must be less than 90. Our significance level is 0.05, rounding off to 4 decimal places. And effect size and effect type and so forth, these are for higher level data analysis. It's a single sample t-test, and we enter our raw data. Okay, so let us copy the data from our Google Sheets, Control C, and paste it. And I think there is an option to, with regards to the outliers, to exclude the outliers, right? These are extreme values, like 6 minutes. I mean, come on, 0 minutes practicing maths. Okay, so these values can be excluded, and let's calculate. And voila, we have our APA style reporting. We've got our statistics, meaning p-value, the t, the sample size, and so forth. So we can copy this and paste it in our, right, paste it in our research document. And we are talking about average time. So we have to state our pair of hypotheses, our pair of hypotheses. Population mean is equal to 90. Population mean is less than 90. We can go to insert equations, H 0. Population mean, we can get this from the Greek alphabet right here, conveniently. It's equal to 90. That's so null, or the null normally is 4. So each null remains. Non-italic. Like alternative, we can use A for alternative or 1 for alternative. And we are hypothesizing, well, okay, the population mean must be less than 90, because we got a value of 58 for our sample. And now our p-value is, that's that negative 13. That's e to the negative 13. That means we've got 13 zeros in front of that 2. So 0 point, and then 12 more zeros before you meet that 2. So that's a very, very small value. That's this calculator way of denoting very small values. Instead of writing 0.013 zeros, you can easily condense it in that way. So that's a very small value. That's not 2.3, that's 0.00013 times, 12 times, sorry, before you read the 2. No, this is a very small, so you have to reject the null. This statement has to be rejected. Okay, it mean cannot be equal to 90. 58 is far from 90, so it means that the population mean appears to be less than 90. Okay, so AP is saying that the results of the one sample t-test indicated that there is a significant large difference between the group 1, which is the population, which is a sample, yes, with a mean of 44. I mean, it's 44 or 58? Give 44, so it must be, we'll have to check that, but anyways, we get the idea. And a standard deviation of 24 compared to 90 for the population. So therefore now, that decision criteria, let us revise where we got that from. Let's go to unit 9 in CI3QYBO. Weekly notes number 9, hypothesis testing. Let's look for p-value approach. Decision criteria, it says reject the null if the p-value is less than the significance level. Do not reject the null if the p-value is greater than the significance level. Our significance level is 0.05. We established that from the beginning, and our p-value is a very small value. So this is less than the significance level. So therefore, we have to reject the null and to conclude that there is a significance, okay, difference between sample mean, the hypothesized mean, and the sample mean, that the mean is significantly less, 34 is significantly less than 90. So basically, we can state the decision criteria, but we understand it, but just for learning purposes, since the p value of 0 point, that's one already, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 2, 6, 3, 5, less than the significance level. By the way, the symbol for significance level is alpha. It's a Greek symbol. Probably because significance have an A in it, and S is already used for sample standard deviation, and all the letters are taken already for other things. So they use alpha of how much? 0.05. The null hypothesis is rejected. So this hypothesis there is rejected. The mean is not equal to 90. It is actually significantly less than 90. And this, you can leave that in APS format. And here are the statistics. That's your second table. And we are talking about, for the mean, let's specify that there's between the group, between yes, we're talking about time. So between the times spent practicing math 4, okay, for group 1, which is sample and the population. So we are comparing the sample and the population, single samples details. So you go to specify the variable that we are dealing with. Single sample t-test using an online calculator.